Hi everyone, for this lesson we are going to be working with algebraic expressions, specifically how to write algebraic expressions and evaluate them using the order of operations. And by the end of this lesson you should be able to answer these questions. How do you evaluate an algebraic expression, and what does the order of operations state? But before we move forward, I want to establish some basic vocabulary skills for this lesson. And we're going to start by reviewing what a variable is. A variable is a letter that stands for a number. So in this case, I have an example that x, our letter, is equal to 6, our number. And when we're working with algebraic expressions, that's a mathematical phrase that contains variables, numbers, and operation symbols. So if you take a look at this example, we have two numbers, m, which is our variable, and addition, which is our operation symbol. All of those things in an algebraic expression. In order to evaluate, because we're going to be doing that today, that means to replace a variable with a number and then make sure that you're following that order of operations. And the order of operations states that you can remember the order of operations by using any acronym that you might have used to remember it, but I've always used "Please excuse my dear Aunt Sally." P standing for parentheses, exponents, multiplication, division, addition, and subtraction. However, I want to make sure that we have a really strong understanding of what the order of operations is all about. Have you ever thought or had the impression that multiplication should always be before addition or before division? It's not necessarily true. If you have multiplication and division present in your algebraic expression, you're going to solve them from left to right, just like you do when you read. Multiplication and division are on the same playing field, and the same with addition and subtraction. So if they're both there, you aren't going to just focus on multiplication first. If division is on the left, then you're going to do that. And we'll take a look at an example together. And just to break it down, these are our order of operations and their symbols of what they look like. So if you need to pause this video, I would encourage you to do so, to jot this chart down if that would help you. Otherwise, we're going to move forward to talking about writing algebraic expressions. Algebraic expressions can be written in word phrases. And if you take a look here, this is just our first example. 3 more than a number can be written as x plus 3. 3 more than a number. And we can use these hints inside our word phrases, such as more than. We know that that's addition. Or the product of, that's the answer to a multiplication problem. Or less than would be dealing with subtraction. So we're going to practice using the order of operations, evaluating, and word phrases and algebraic expressions. So let's go ahead and take a look at what that is. Here we're asked to write an expression for 3 more than the product of 8 and a number. Well, geez, where do we even start with that? We're actually going to go a little bit backwards. I know that right here where it says product, I know that we're going to be working with multiplication. And we're going to be multiplying 8 and a number. So we can either write that as 8, and I'm going to use n for our number, or 8 times n. The reason why I'm not using the x as our multiplication is so that we're not confusing that with another variable. So we have the product of 8 and a number more than. So 3 more than a product of 8 and a number. So we would add 3 to that expression. 3 more than product of 8 and a number. So that's just an example of how to write an expression. Next, we're going to write a word phrase for an expression. Our expression is n minus 9. And there's a couple ways that we can write this, but obviously we're working with subtraction. And my favorite way to write a word phrase dealing with subtraction is subtracted from. So we're going to have 8 subtracted from a number. Ooh, sorry, that's a little sloppy. Subtracted from a number. And if I go back to that chart that I showed you earlier, dealing with, if we look at the subtraction section, we could have also written it as 8 less than a number. Whatever way is you feel most comfortable with is fine with me. Next, we're going to work on a problem dealing with using the order of operations. So we have 4 numbers here, and we have 3 different operations present. We have subtraction, multiplication, and division. We don't have parentheses, so I'm going to cross that out, or exponents. Now I'm going to focus on multiplying. So I'm going to underline here, we're going to multiply 4 times 3. Following the order of operations, that's what I'm going to do first. 4 times 3 is 12, and I'm just going to drop down the rest of our expression. 16 minus 12 plus 20. Now I'm left with subtraction and addition. And like I said in the previous slides, addition and subtraction are on the same playing field. We don't have to do addition first. So we're going to work from left to right, just like how we read, and we're going to subtract 12 from 16, which is 4. We're going to drop down the rest of our expression, plus 20. We're going to add 4 plus 20 equals 24. And we just solved that expression using the order of operations. Now in this problem, we're also going to use the order of operations along with evaluating for not only 1, but 2 variables. So in this expression, we are asked to evaluate y for the value of 4 and the variable n for 5.6. So let's rewrite this expression evaluating n for our variables. So we have 6. And inside our parentheses, we have 8 plus y, which we're replacing y with 4, times n, which is 5.6. Following the order of operations, we're going to work inside our parentheses first. So 8 plus 4 is 12, and I'm going to drop down the rest of my expression, multiplied by 6 times 5.6. And working from left to right, we're going to multiply 6 times 12 first, which is 72. And 72 is being multiplied by 5.6. And the product of 72 and 5.6 is equal to 403.2. And that is how you evaluate an expression using the order of operations. And that brings us to the end of our lesson, so let's go ahead and review and see if you can answer these questions. How do you evaluate an algebraic expression, and what does the order of operations state? If you have any questions regarding this lesson, please don't hesitate to let me know.